Have you ever closed your eyes and just wondered what space sounds like? We see all these amazing pictures, but what about actually hearing the universe?
It's such a cool thought, right? And it turns out space isn't silent at all. Scientists are using sound to explore the universe in ways we never could have pictured, well, heard.
Okay, now that is something I got to know more about. So we're diving into an article today all about this, and let me tell you, I'm already hooked. So how do we hear space? What are we listening to out there?
It's all about this process called sonification. Basically, it's like taking data from telescopes and turning it into sound. You know how telescopes capture light, and that light carries all this info about stars and galaxies and everything.
Right, right. Like how different colors of light can tell us, like the temperature of a star or what it's made of, that kind of thing.
Exactly.
Hmm.
Sonification takes that same idea but uses sound instead of light. So instead of just seeing those patterns in the data, we can hear them, like changes in pitch or volume, even rhythm. It's like we're translating the secrets of the universe, but for our ears.
Wow, that's kind of poetic, actually. So it's not just looking at a picture, it's like listening to a whole symphony of data.
That's a great way to put it.
Yeah.
And it's not just about making space cooler, though it definitely does that. It's seriously changing how we do science.
Okay, how so? Give me the specifics.
Well, think about it. Our eyes, they can only process so much information at once, right? But our ears, they're really good at picking up these subtle patterns, little changes, stuff we might miss just by looking at graphs and charts. So listening to the data lets scientists discover things they might have totally missed before.
So we're talking about brand new discoveries, all thanks to sound.
Oh, absolutely. We're using multiple senses to understand the universe now, not just sight. And, it also makes astronomy research more inclusive for people who are visually impaired. They can
Mhm.
experience the wonders of space in a whole new way, which is fantastic.
Now, that is what I call opening up the universe for everyone. I love it. But let's get down to brass tacks here. How does this actually work? I mean, how do you turn a supernova, for example, into something you can hear?
Imagine, like, listening to a Hubble image. Bright stars, they become these high, shimmering tones. And those dark, mysterious nebulae, they turn into deep, resonant hums.
Okay, now that's something I gotta hear. So we can literally listen to a picture of space. That's pretty wild. But what about actual events? Like if we could hear a supernova, what would that sound like?
Oh, supernovae or something else. Imagine, like, a giant orchestra, but everyone's gone a little crazy, just playing their instruments as loud and chaotically as possible. That's kind of the vibe.
Okay, yeah, that's definitely way more intense than just seeing a bright light in the sky.
Right. And it gets even cooler. We can actually break that sound down into the individual elements that are, exploding. Our source mentions Cassia, this supernova remnant,
Mhm.
basically a huge cloud of debris from a star that blew up a long time ago.
Ah, right, a supernova remnant. Like a cosmic crime scene, but with sound.
Exactly. And by listening to the sonified data from Cassia, scientists can hear that each element, like iron, calcium, each one has a unique sound signature. It's like listening to the star's shattered guts scattered across space.
That is both beautiful and terrifying. So we've heard of stars' explosive death, but what about those mysterious objects left behind? Black holes are often called silent giants, but they've got to make some kind of sound, right?
They do. And it's not what you'd expect. See, we can't actually hear anything from inside a black hole.
Wait, why not? Spill the tea.
Things get a little heavy with the physics here, but basically, black holes have such strong gravity that nothing, not even light, can escape once it crosses over the edge. This point of no return called the event horizon.
Okay, yeah, I vaguely remember that from somewhere. Black holes are weird.
Totally weird, but awesome. So even though we can't hear anything from inside the region around a black hole, that's a different story.
So what are we hearing then? Is it like the sound of stuff getting sucked in?
You got it. As matter gets pulled into a black hole, it heats up like crazy, millions of degrees, and emits X-rays. We can sonify those X-rays, and what you get is this eerie rising pitch as the matter spins faster and faster, like a cosmic drain.
A cosmic drain, huh? Terrifying, but also really cool.
It really gives you a feel for the power of these things.
Mhm.
But hey, it's not all doom and gloom out there. What about those beautiful nebulae, those colorful clouds we always see in pictures? Is there a sound to star formation?
Oh man, I've always wondered about that. They always look so peaceful and serene.
Peaceful might not be the right word. Nebulae are more like giant cosmic nurseries, bustling with action as stars are born. Imagine a bubbling cauldron, all pops and crackles as new stars ignite. It's less of a clear melody, more of a wild, untamed soundscape.
Whoa, so what's creating all that sound in a nebula? It's not like little baby stars having a campfire sing-along, right?
Huh, not quite. Nebulae are massive clouds of gas and dust, and as gravity pulls all that stuff together, it collides, creates friction, generates incredible heat, all that activity. That's sound waves. And through sonification, we can listen in on that whole chaotic, beautiful process of starbirth.
My mind is officially blown. Exploding stars, black holes eating matter, stars being born, we've experienced it all through sound. It's incredible to think how much more is out there, just waiting to be heard.
You know, it just occurred to me, scientists use all different kinds of telescopes to see different things in space, right? So how do we combine those sounds, those different perspectives to get the complete picture? It's like we're only getting pieces of the puzzle, right? How do we put it all together, all those different sounds from different telescopes? That's when things get really amazing. Imagine you're at a concert, right? But you can only hear the drums. You got the beat, the rhythm, but you're missing so much. Then boom, someone gives you headphones, but these are tuned to just the violins. Suddenly, it's a whole new layer of sound, a whole new feeling. That's what it's like combining data from different telescopes.
So it's like we've got James Webb showing us infrared, all the heat out there, and then there's Chandra showing us X-rays, the really powerful stuff.
Exactly. Each telescope, it's like a different instrument, tuned to a specific part of the electromagnetic spectrum. It's like, you know how we have the visible light spectrum, all the colors we can see? Well, the electromagnetic spectrum is way bigger. Includes things like infrared, ultraviolet, X-rays, all invisible to us.
Right, like some animals can see ultraviolet light, but we can't, right?
Exactly. And each part of that electromagnetic spectrum, it's like a different piece of information about the universe. Like each color tells us something different. When we combine data from all those wavelengths, it's like hearing the full orchestra, not just a couple instruments.
So we're not just seeing more, we're understanding more by combining everything.
Absolutely. And sonification, it makes this even more powerful. Imagine you're hearing this faint whisper of gas clouds collapsing into stars. But at the same time, you feel the booming bass of a supernova explosion nearby. It's this crazy multi-sensory experience. You're immersed in the universe.
Okay, last question, and it's a big one. What if we could send a microphone out into space, like way out there beyond our solar system? What do you think we'd hear?
That's the million-dollar question.
Yeah.
We barely even started to listen to the universe.
Hmm.
I gotta say, I think it's probably more complex, more beautiful, and yeah, maybe even scarier than we can imagine right now. Who knows? Out there, maybe there are entire symphonies going on just waiting for us.
Okay, now those are some goosebump-worthy thoughts right there. For everyone listening, I'm giving you homework.
Yeah.
Go check out some sonified space data online. There's some incredible stuff out there. Seriously, your ears will thank you. And on that note, we're wrapping up another deep dive. Until next time, keep exploring.